What's poppin', dogs? Mr. Allen here with a doozy of a problem in the world of polynomials. We are given that x equals 4i is a zero of some polynomial p of x, this guy right here, and we want to find all other zeros and write p of x as a product of linear factors. Whew. All right, well, first thing here, I've got a degree of 4, okay? I've got a degree of 4 here for my polynomial. Exponent's 4, that's the degree of 4. That's my lead coefficient for two different things. But that means that I'm going to have 4 total zeros, okay? 4 total zeros. That can be a combination of real and imaginary zeros. But one thing to remember about imaginary zeros is that they always come in pairs. So if 4i is one of my zeros, the other one has to be negative 4i. You might be like, wait, why? Why does it have to be negative 4i? Why not something else? Well, let's think about how 4i even came about. It came about from square rooting a negative number. The square root of what number would give me 4? Square root of 16 would do that. So check this out. If I take this 4i here, I'm going to do this off to the side and work my way back this way. If I take this 4i, so x equals 4i, I know that came from, if I square both sides, I get x squared equals 4 squared is 16, I squared is negative 1. This came from x squared equals negative 16, right? If I square root both sides, I get plus or minus 4i. Now, if I were to set this equal to 0, I get basically one of my factors. So I would add 16 to both sides. So x squared plus 16 equals 0. So I'd get one of my essentially factors. It's not a linear factor, but it is a factor no less that I could take out of this polynomial right here using long division. Okay, so I did a little bit of backwards math. Some people are totally fine just thinking like, okay, I've got x equals 4i. I know that comes from square rooting negative 16, so this is my factor. And you'll see that common pattern quite a bit in these types of problems that you might just be like pretty quick with it, and you don't have to write it all out every single time. But I like to show you guys that so you can see where it came from and not just magic, all right? So that being said, we are asked to find all of our zeros. So over here, I'm going to start a little checklist, if you will. X equals 4i is one of them. X equals negative 4i. We'll have x equals 2 other things that will pop in over there. But whether the answer line is down there in your test or whatever, I like to make sure that I have a little spot for everything so that I don't forget to put my final answers after I do all the heavy lifting of math, all right? So now we got to take care of this guy, all right? And what do I mean by that? Well, I want to divide that out of my polynomial here so that I'm left with a quadratic that I can either factor or use quadratic formula to solve, okay? Why did I know that's going to be a quadratic? Well, if I have a degree of 4 here and this is a degree of 2, when I divide that out, I'm left with another degree of 2, okay? So I've divided out basically 2 factors out of my total 4 that are going to exist here, and I'll get my other 2 zeros, all right? So let's set that up, and you're going to need a decent amount of space to do this because it is long division. It takes a bit of time, okay? So my x squared plus 16, a key thing to remember, I'm probably going to need a lot of space here actually, is that x squared plus 0x plus 16 is how I'm going to want to write this thing. I need that placeholder for the x right there, okay? Otherwise, your organization is going to get all off, things are going to get out of line, so I always like to put in that placeholder. Then I'm going to put my polynomial here, the 4x squared minus, 4x to the 4th minus 5x to the 3rd plus 65x squared minus 80x plus 16. Okay, there we go. Don't want to screw that up right off the bat. I've made mistakes on this one before. Maybe I'll pop that in here. It's pretty hilarious. All right. Let's hope for no mistakes here. So first thing, I'm going to take this 4x to the 4th, and I'm going to divide it by that x squared, okay? So with polynomial long division, we're always focusing on this first guy here, and then the first thing here, and we'll work our way down the first terms that exist as we work our way through long division. But this is my key dude right here, and I'm going to use a different color each time so you can see where everything came from. So if I take 4x to the 4th and divide it by x squared, I'm left with 4x squared. Now, some folks like to put this over the squared term. Some put it over here. I don't really care. All right, just make sure you're organized in some way, shape, or form, or do whatever your teacher asks you to do. All right. Then I'm going to take this 4x squared. I'm going to multiply it through each one of these and write them below their like terms. This is where lining up your like terms really matters. Up here, whatever. All right, 4x squared times x squared. is 4x to the fourth. These two, when multiplied together, will always give you the thing that you were trying to get over here, right? The thing that we were dividing over here. They should always match up because they're going to cancel out. 4x squared times 0x is 0x. So plus 0x to the third. And then 16 times 4, that's what? 64x squared. Okay. Next up, we got to subtract the pink stuff from the green stuff. So I like this little rhyme here. We got to draw my line, change the sign. Everything becomes subtraction there. I distribute through my subtraction so that way I don't miss one of my subtractions of like 3 terms. Okay, you could just be like, I'm just going to subtract everything and be totally fine with that. Awesome. I like to distribute my subtraction through. It's just how I do it. This cancels. This guy right here is negative 5x cubed minus 0x. That's just negative 5x cubed. Over here, I have 65 minus 64. That's going to be positive 1x squared. Drop down my next term here. Boom. We're going to start this process all over again. I'm going to use orange next time. So now I'm looking at my x squared and my negative 5x cubed. Again, first term over here. New first term right here. Divide these two, I get negative 5x. Just negative 5x. There we go. Negative 5x. Boom. And then I'm going to distribute through again. So negative 5x times this is negative 5x cubed. These two should always match up. We're going to get the 0x squared plus 0x squared. Negative 5, 16, that's what, negative 80x. All right. Cool. Beautiful. Is that negative 80? Yes, negative 80. Okay, cool. Don't want to make a mistake. All right. Next, I'm going to subtract. So draw my line, change the sign, and those cancel. They always will. This right here is just x squared. It's 1x squared minus 0x squared. And then here, those cancel. So plus 0x. Drop it like it's hot. Boom. Start it all over. If you can get the 3 steps that exist in this, you're fine. Okay? It's easy to make a little mistake in here, screw things up, and then the whole entire problem is ruined, basically. So be very careful in your long division. As I'm saying this, I'm just hoping again that I didn't make any mistakes because I have in the past, guys. All right. Everybody makes mistakes. X squared divided by x squared is positive 1. So 1 times x squared is just x squared. 1 times 0x is just 0x. And 1 times 16 is just 16. And one key point here, draw my line, change the sign, is that everything should cancel out at the end, leaving me with a remainder of 0, because we know x squared plus 16 can be divided out of this polynomial because it was created from one of my known, actually 2 of my known zeros, 4i and negative 4i. So if you don't get 0 for your remainder, something went wrong, okay? All right, so now I have this quadratic. Okay, let's write this up. I've got this wonderful quadratic. I will go with it's all sorts of different colors. I'm going to write it right here. In green, I have 4x squared minus 5x plus 1. We'll set that equal to 0 to find my other zeros. First thing I'm going to do is I'm going to see if I can factor this, right? Factoring is my go-to every single time for solving quadratics, if possible. That and square roots are the 2 easiest things. I can't use square roots because I have a linear term, but I might be able to factor, and if not, I'll resolve to quadratic formula. And I'm hoping I don't have to do quadratic formula because I don't have a whole lot of room left. Well, 4 times 1 is 4. Does anything multiply to positive 4 while adding to negative 5? Yes. Negative 4, negative 1. Therefore, this thing is factorable. I am going to try to do guess and check here. I would urge you to get better at guess and check as well because, generally speaking, it is the quickest way to do things. It takes a little bit of practice. It's not always the quickest method, but with small numbers and prime numbers or numbers with limited factors, it can be pretty quick. So I know the only way to get positive 1 is going to be 1 and 1 or negative 1 and negative 1. And since it needs to add to a negative, I know these are both going to be negative 1s. Okay? I'm kind of guessing and checking with that term rather than the first term because 4x squared can be done with 4x and x or 2x and 2x. But let's see if 4x and x work here. That would give me negative 4x. That would give me negative 1x. Does that add up to negative 5x? It does. Right? Negative 4x, negative 1x, negative 5x. Boom. We guessed. We checked. Now we can set these equal to 0 and solve. 4x minus 1 equals 0. So x is going to equal 1/4. Over here, I got x minus 1 equals 0. So x is going to equal 1. So there we go. Boom. 1/4. 1. I've got all 4 of my zeros. And let's see here. It says find all other zeros. Boom. We're good. Sometimes they want you to write all 4. Sometimes they say all other, so they just want you to write the other 3. just read it, you know, make sure you answer. A lot of times I just write all of them there, and that's usually what they want. I'm the teacher. I wrote the problem. Anywho, and now I got to write it as a product of linear factors. So first off, function notation is key here, guys. Half points off if you don't do that, all right? Or whatever your teacher says it's going to be. I do half points off if you don't have function notation and it asks you to write a function, okay? Write P of x. P of x equals. Easy peasy, okay? These two are two of my factors. So 4x minus 1, x minus 1. And then my other linear factors are going to be, well, x minus 4i. And so that was for this one here, x minus this. And then x minus this would be x minus negative 4i, so x plus 4i. These would be your linear factors, all right? All right, there we go. We got it all. Nice. Sometimes they do also ask this other question. I didn't ask it here, but they may say, you know, write it in factored form with only real numbers. In that case, you would have still these two factors, 4x minus 1, x minus 1, and then you do the x squared plus 16 so that you have all real numbers and no imaginary numbers. But this one, the orange one, is the one that's the product of linear factors because everything is a degree of 1 here, okay? So this was what the problem actually, that's a terrible star, actually asked for, but the other one there could be a suitable answer if they only want real numbers, so just other things to look for. But anyways, guys, that's it for this one. It is a doozy. It's a lot of work, a lot of you know, long division fun. But the key start here is that you have x equals 4i. So that has to come from square rooting negative 16. And that way I got my x squared plus 16 equals 0 as one of my factors, not my linear factors, but one of my factors that I can divide out of that quartic function right there. Dope. Awesome. Well, if you guys have any questions, pop them in the comments. If you want another video like it or something different, let me know. But otherwise, thanks for watching and have a great day.